Hi Radio TechCon. My name's Caleb Epps, aka Necobus, and today I'll be talking to you about audio for VR, audio for AR, and how I envision the future of audio across these new devices. Thank you so much for having me to talk to you today. And first off, I'm going to give you sort of a quick look of what we're building and what you can build inside of Horizon, and then we'll get into it. See you in a moment. Thank you all for having me, as I said before. What you just saw was some bits from Facebook Horizon, which is a game, an app that we're working on. Meet up in virtual reality wearing a headset like this. This is an Oculus Quest 2. It's relatively newly released a couple months ago. And to also build worlds together, and you can make games, you can make hangout spaces, you can make all sorts of things. So to introduce myself a little bit more than I did before, my name is Caleb Epps, and as I said, I'm a sound design manager at Facebook. So what I do at Facebook is sort of twofold. One is that I'm part of the immersive sound design team. We are the team responsible for sort of around audio. That includes sort of everything from audio for effects on your phone to helping out in partnership with Facebook, all the way up to sort of researching and developing things like audio APIs, which is something that we're working on, which I'm not wearing. These are normal glasses. But yeah, so that's sort of what I do. Before I was at Facebook, I've spent the past dozen years working on a variety of video games, everything from Rock Band. I worked on the Rock Band series for a while, got to go to Abbey Road to work with the Beatles, which was really cool, and all the way on to making shooters like Call of Duty, as well as a bunch of indie games and other fun things like that. So that was me. So we're going to talk first. We're going to talk about audio for VR. So VR, virtual reality, 3D. It is stereo audio delivered directly either out of the headset. There are speakers here on the sides of this, inside the strap on these units, or via headphones. So as it stands, making audio for a VR experience is not that dissimilar from making audio for a game world. So what you need to do is you need to, generally set a scene. We generally use an ambisonic, usually a third-order ambisonic bed to cover sort of the background mix of a world, and I'll talk more about ambisonic audio in a minute. And then we use monaural point source sound effects that are run through our game engine. For Horizon, we use a sort of not bootleg, but sort of duct taped together and modified version of the Unity game engine, but people use their own game engines or Unreal or various other tools to make games in VR. And we run those monaural sounds through the game engine through a spatializer, which applies what's called an HRTF, head-related transfer function, which we'll talk about more soon, to come out of the ears as binaural audio. As I said, rather than when you're making sound for games, you need to think about, okay, sound for stereo, sound for headphones, a mix for 5.1, a mix for 7.1, object-oriented mixes such as, mix for Atmos and whatever new. But for VR, you're really just thinking about either a device mix or a headphone mix that can be plugged into the side of the device. Now, for Horizon, which is in closed beta right now. And if people have and want to give it a try, and I can get you a code for access, and we can hang out in VR. It'll be great. But for Horizon, audio presence, which is a term I'll explain in a moment, is really our first measure of quality, and that's what we're mixing around. So when I talk about audio presence, what I really mean is for a user being heard and hearing others. So basically, voice over IP, right? Because we are running this through a binaural mix, we really think about recentering our audio experience around sort of normal human perception. If you sort of take a step back and philosophically think about it, we've flattened our sort of audio experience down to a couple of speakers in order to represent a live band on stage, or a couple of earphones with a flat sort of direct pipe in order to simulate human conversation. But what we're now doing is we're actually bringing it back to, okay, a person is standing right here and talking to me, and it sounds like they're standing right here and talking to me, and that leans on our normal faculties as humans to listen to audio in that way. And that actually removes a little bit of the cognitive load of sort of decoding, okay, this flat thing, I need to sort of translate that into the idea of a person who's actually speaking to me. So when you're thinking about transmitting voice over the internet, or over any network, over the course of the history of that technology, we've actually focused a lot on network bandwidth optimization and, focusing on sort of removing audio quality in order to focus on intelligibility, right? To sort of squash down the frequency spectrum that we're sending through. And that can actually harm and remove some of the subtleties in human speech that can really improve the sense of audio presence. So for audio presence in Horizon, we're really thinking about what I said before, spatializing voice chat, and centering our mix around voice. In most games, actually, voice isn't really considered part of the mix. The consideration is that, well, our users will use things like Discord or usually Discord, or some other sort of OS level, operating system level voice chat, like on the PlayStation or the Xbox, in order to communicate with each other. And it's not really considered part of the mix. Maybe a mix will be smart enough to, duck parts of the mix in order to make room for voice chat and have sort of, a side-chained compressor running against the mix when voice chat comes through, but that's usually a pretty rough scoop and not a sort of really considered part of the mix. But voice is going all the time in Horizon, so it's the center of our mix. So let's talk quickly about Ambisonics. So Ambisonics was developed in the 1970s, right there, not here. This is California, in the UK, way. And it is a sort of spherical sound format that creates a sphere, basically a sound bubble around the listener. And this actually can be comprised of as little as 4 channels or represent a full sphere. Going up from that, what we use in Horizon is actually third order Ambisonics, which uses 16 channels. It's not quite as good spatial fidelity as you found, and running it through a head-related transfer function. Takes sort of a bunch of different math and bangs it all together. And then you can basically use that in order to position a sound in space around a listener, right? So it's basically representing each person's ear based normally on a sort of ideal or sort of normal head size and ear spacing, and sort of filters sound in order to represent how you would perceive that sound from a point in space. We provide functionality to do this in a thing called the Oculus Spatializer, and we provide a bunch of tools for that. But as I sort of am going back, we have sort of 2 spatial formats that compete with each other that we're using inside of Horizon. One is that we're sending mono sources through HRTF. We can do that. But the problem with that is that you have to run that on these headsets, right? And so we're constantly having to think, this is not really necessarily something that you need to think about in radio, but how much processor are we using up in order to and render all these sounds, and the game needs to run at hopefully 120-ish frames per second, because you need to render 2 frames, one for each eye, in order to achieve a 3D effect. And so our format implications are actually really important to us. So mono via HRTF provides really high quality spatialization, but the processor uses scales essentially linearly with our voice count. So, and in generally not spatializing certain audio sources. Some games I found, have been juggling sources in and out of spatialization. It can really adversely affect the overall spatial mix. If you have a lot of people, when they start working in spatial audio, complain, well, I was listening to this sound in my DAW, sounds awesome, I run it through a spatializer, and now it is robbed of some of its power. The reason for that is that we need to make some EQ adjustments, some frequency adjustments in order to properly spatialize it. And when you start to have a mixture of those two elements, some non-spatialized audio and some spatialized audio, it can actually cause the resolution of the spatial mix to collapse. And so what we really wanted to do is we wanted to sort of actually use a little bit from Ambisonics and a little bit from HRTF in order to achieve maximal spatial fidelity, while also allowing us to carry as many voices as we want. So Ambisonics, as I've said before, has slightly lower quality spatialization if you're using a third-order ambisonic. First-order ambisonic, actually, that spatial quality goes down quite a bit. The initial processor usage, because we're carrying 16 channels of audio, that is quite high. However, adding additional voices, which we're actually mixing on a server, and then sending an individual ambisonic mix to each user in Horizon, it means having one person speaking through an ambisonic mix and having 100 people speaking through an ambisonic mix is essentially the same cost. So using Ambisonics, we're actually able to scale the ability for people to talk to each other as high as we want for the same cost, for the same network bandwidth, and for the same, we're paying a bunch of cost on a server in order to mix all those voices together. But in terms of the network bandwidth up and down, it's a mono feed up from microphone out of this headset, and then a 16-channel feed down for a third-order ambisonic, all mixed together for all the voice chat. But what we're pushing on now is like this non-existent GIF, which is a little girl saying, why can't we have both? Oh, there we are. We did it. What we're actually doing we're working on this right now in Horizon, is actually mixing mono HRTF processed sources and ambisonic. We can push our ambisonic mix down to first order, which uses 4 tracks. And then that frees up our ability to prioritize certain mono voices to be sent through at higher quality per user, based on things like distance, based on whether they're your friends, and based on a number of other factors, many secret sauces, in order to prioritize high quality spatialization for important sources, and then to deprioritize other voices, making sure that you can hear them and making sure that they're spatially rendered, but with lower quality. And we found that the overall quality appears to be higher, and we're actually able to throttle our network bandwidth based on the number of high quality voices that we want to render, given that freed up space. And I think my controller just hit something. So now we need to move from VR to AR. So VR is sort of more akin to a PC session length. This takes up your entire field of view, your entire sort of sensorial experience. And you're in a fixed location. You can move around with this, but once you put this on, you don't really want to, because you might crash into things. and it's really using dedicated time. Now, AR, and this is a picture of a pair of our sort of new research glasses that we're working on right now, that we'll start deploying out early this coming year for some limited testing out in the wild to gain some, some valuable insights. It's more akin to a mobile phone session. It's ubiquitous. You're using it in short sessions throughout the day. So, what are we working on in AR? And there's a link here to Michael Abrash's Facebook Connect presentation from a couple of months ago. But in these glasses, we're including beamforming microarrays in order to pick up your voice. This is technology that's already present in a lot of earbuds. We're working on personalizing HRTF functions per user based on photographs of people's ears in order to increase spatial resolution. And then we're also working on real-time spatial reverb and propagation, so that sounds not only sound like they're coming from where they are in virtual space, but that they will properly bounce around the room based on the room geometry. To talk a little bit about reverb, and I'll do this very quickly, we've started with things like, and this is all in the video game space, with things like delay line reverb, which you'll hear in Overwatch. It uses a quadraphonic delay line reverb based on the level geometry in the game. We use convolution reverb all the time. And then there's some new technology being worked on by Microsoft, which uses sort of wave flowing technology in order to make a propagation map across a game space. There's a link to a couple of really great game developer conferences talks on this tech here. And then we at Oculus are using directionally spatialized reverb in order to sort of represent spaces. And just adding like a few reflection bounces can really go a long way to provide like really awesome spatial presence. So, to wrap this all up, because time is running short and I've been talking very quickly, spatial audio is happening right now. And so it's an enormous opportunity for audio. For an all-day wearable device, you'll notice these glasses are small and there's not a lot of room for batteries. So running a display is going to be really hard to do that, especially to do that all day, and especially in the early days of these devices. And that gives audio an enormous opportunity to step up and to be sort of the forward-facing interface for how people interact with these glasses. So what do? We need to consider the context of spatial audio, and we need to sort of sit audio content into a new spatial mix that will be created as part of these devices. So something to consider is location, whether you want to fix your audio sources on the head so that they turn with a user. Maybe they'll be fixed on a body so that they attach to somebody's shoulder. Maybe they're fixed somewhere in the world, so if you walk by them, they will sort of spatialize appropriately. And using non-diegetic sounds, sound that like just pipes into your ears like music, is generally sort of, I'd like to discourage it in the sort of spatial landscape, but it can really, it's really something to think about and consider.